Okay, question number 7. So I can understand why folk might look at this and think this looks quite tricky. Yeah, I can see that. But at its core, what we've got here is a fractions question. Okay, so I've been over in the earlier videos. I think it'll be the first video. There's always a fraction question about the different rules. So I'll just go straight to the division rule here. So I always talk about KFC. Okay. Um, I always talk about it, but enough of that. Let's talk about fractions. For this, it's KFC. Okay, so it's keep, flip, change. I've had KFC in ages. I do love KFC. Other fried chicken is available. Right, keep, flip, change. That is meant to be too easy. So when you see this, think KFC. So we keep the first bit the same. So we're going to have 5t over s. I can see this getting confusing, so I'm going to do my handwriting is going to ruin me, and I'm going to have a 5t divided by s. So we keep that the same. We flip the second term. So we get 2s squared divided by t, and then we change the sign from a divide to a multiply. Okay, so keep, flip, change, straightforward. Now this uses our second rule, or one of two rules or not one of two rules, it uses another rule. We've used one rule, here's another rule for fractions, okay? Explain stuff terribly, sorry. 10, I'll say s squared t, I'll put the indices in that order. Okay, so I've just done 5 times 2, s squared and t. Okay, and then on the bottom, that was an s. That's what I mean by handwriting. An s and a t. Okay, so now we need to cancel things out. Okay, so that's probably the first part. They want to know if you could divide fractions, and now we cancel. So we can cancel a t, and we can cancel an s from the bottom and make that 1. Okay, so that is going to give me 10 s to the 1. But do we usually write that? Not really. We just write 10s. Okay, and that'll be your final answer. So you're getting a mark for understanding keep, flip, change. You're getting a mark to follow through, and then you're getting a mark for simplification. Okay. It does not mention if you would get a mark for having s to the 1. I don't see why not. But yeah, that's better notation. We don't usually write the 1. We take it as read that is 1. Okay. So yeah, keep, flip, change. James paid this amount for a laptop in a sale. The discount in the sale was 15%. Calculate the original price. Okay, so when we're doing percentages, probably the main thing to know is your decimalisation, like we said before. Okay, so if we do 100 plus or minus 15 divided by 100, that's going to tell us a decimalisation. Okay, so the laptop there, discount of 15%, that would end up giving us 0.85. So if we want to reduce something by 15%, 0.85. So that's the kind of first thing that you learn when you do your percentages. We did a compound interest question earlier on. So if we want to take 15% off something for 5 years, we do it to the pound of 5. So whatever it was, it's £10,000 times that. So we're reducing that amount by 15% for 5 years. Okay, we learned that as well. We also talk about the difference over original, which is the percentage increase in something. Okay, difference over original. So if I've got, let's look at this laptop. Okay, so say the laptop, was £400. It's now that. What's the percentage change? Well, what's the difference? Well, it's 400 take away 297.50. Difference over original, just 400. Okay, so difference over original gives us our percentage change. But this question is actually the other type of percentage we're going to be looking at, which is reverse the change. Okay, so we know the discount is 15%, and that's the amount after the discount. Okay, so we had 100%. We don't know what that was. Someone took off 15%. We get 85%. And we know that amount is 297.50. Okay, so how do we work out what 100% is? Well, we can't just figure out 15%. We couldn't say, for example, well, times by 1.15. Okay, because that would increase it by 15%. Yes, but it would increase the 85% by 15%. So with 15% of 85%. Okay, so we can't do that. What we need to do is work out 1%. and then multiply up to get 100%. Okay, so how do I get from 85 to 1? I'll do 85 divided by 85. So let's do the same on here because it's like a, it is an equation. So what we do to one side, we have to do to the other side. Okay, so 85 divided by 85 gives me 1%. So then 297.50 divided by 85 gives me £3.50. Okay, I'm just going to do 2 decimal places for money. So that's 1%. How do I get up to 100%? Well, from 1 to 100, I've got to times by 100. Just do the same again on this side. Times by 100. So that's going to give me 300, pardon me, and £50. Sounds easy enough, doesn't it? So the only thing that was tricky there was identifying the question. Okay, the actual question itself is very simple. Okay, so reverse the change. When you see, there's been a discount in this, calculate the original price. That's your reverse the change. Okay, there was a percentage change. What was the original? Okay, reverse the change. Now you could check that again. Okay, so say we said, right, well, if that's true, okay, so if 100% is equal to 350, how would I get from 100 to 85? Well, if I times that by 0.85, that's going to reduce the 100% by 15%, isn't it? So let's just double check that. Let's say 350 times 0.85, and that's 297.50. So you can again, check you've got the right answer, feel confident in what you've got. You don't go through the paper thinking, oh, that was a tough question, that was a tough question. Okay, you can actually check that one as well. So there you go. 350 would be the original one. For this one, you are getting a mark for this first line. You then get a mark for your 1%, then a mark for 100%. Pretty straightforward. Okay, but again, even just writing that, if you know nothing of maths, if you don't understand how to do reverse the change, just stating 85% is equal to that amount, 1 mark. I mean, that's great, isn't it? Don't give up at all, right? That's just knowing that 100% minus 15% is that amount, 1 mark. Okay, if you're not great at working back, the numbers seem too much for you. Okay, don't lose out on that mark. That's a great wee mark. Okay, it was the same with page is gone. Let's just let it start up again. It's the same as the volume question. Just by writing down that equation and substituting in the radius, 1 mark. Okay, forget scientific notation and figures. That's an equation you're given the radius, sub it in, not tricky. Okay, easy mark. I'm sure there was another easy mark somewhere. Well, I thought all this was easy marks because it was just substituting. This one as well, just from the 23 equals 3a plus 2. Writing that down, you get a mark. Okay, so there's all these little marks getting thrown away when you forget units and stuff, but also to get picked up. If you're not great at a topic, think, how do I start it? Okay, or just try something. Okay, and then we can check that, and then that's going to give us some confidence in it. So, okay. Oh, this looks good. This looks good. Oh, this is one of my favourites. This is a similar shaped question by the looks of it. So we've got a flag at each hole in the golf course, and it's coloured red and blue. The diagram represents a flag. Okay, so triangle QRT is the red section. So this bit here is red. And the rectangle is blue. Okay. So suddenly, I don't need to know any of this stuff. Triangles PRS, okay, and QRT are similar. So basically it's saying, we have similar triangles. They share the same angle, which we can see, okay? But they've used the phrase mathematically similar, so that's where you jog in your memory. You should be thinking, right, similar shapes, similar shapes. The area of QRT is 400. Okay, so the red is 400. I'll just say units squared, okay? But yeah, QRT is 400 units squared. Calculate the area of PQTS, the blue section. Okay, so and then it wants to know the blue section. So first of all, I'd be thinking, well, how do I work that out? What's going to be my strategy? Okay, and again, if you know nothing about maths or similar shapes or anything, I think most people can agree that the area of the blue is going to be equal to the area of RPT, take away the area of RQT, okay? I.e., the big triangle take away the small triangle. Yeah, so if we work out this whole area, then take away this one, we're going to be left with the blue area. Okay, and that was meant to be two little repeat marks, and they haven't really worked out very well. I'm going to have to go faster actually because my time's running out. So that'd be a good place to start. Okay, the next thing to do is to always say, all right, well, what's my scale factor? Okay, so scale factor every time, linear scale factor, new over old. Okay, that's always what you want to be thinking. Now our new shape is going to be the big one. Okay, and the old shape is the one we do know. So our new length is 30 and the old one's 24. That's a good place to start. Okay, always what's your strategy and what's your scale factor every single time. Okay, so these two triangles, if I just redrew them on their own like this might make it a wee bit clearer. I've kind of got this, don't I? Where I've got 24 and I've got 30, and I know the area of this is 400. I'm trying to work out the area of this one. Okay, that is 24, not 29. Hey, I hate when I'm against the time, I kind of rush. Okay, so because we're trying to find something in this shape, that's the new one, that's the old one. So that's kind of that distilled. Okay, so you should at least be able to get to here. Okay, now I usually just leave this as a fraction. Um, in the non-calculator paper, if there's a way to simplify it in the non-calculator, you would have to. Here, you don't really have to, but just to practice, what goes into top and bottom? Well, I think 6 would go into top and bottom, yeah. So that'd be 5 over 4, yeah. 6 4s are 24, and 6 5s are 30. So 5 4 is going to be your linear scale factor, okay? So that's a good place to start. Then we're looking at areas, aren't we? So what's our area scale factor going to be? The area scale factor is our linear scale factor squared. So that's going to give us 5 over 4 squared. And again, if it's a non-calculator paper, I would do a non-calculator, so it's 5 over 4 times 5 over 4. So that's 25 over 16. I'm just going to do it this way just because we might come up in a non-calculator paper. I just want to show you. Okay, but you could just have 5 over 4 squared or 30 over 24 squared in this paper because you've got a calculator. Okay, that's the area scale factor. Then how would we possibly work out the area of the blue one? Well, we take the area of the red one, so we would do our 400 times 25 over 16, and that's going to give us the new area. Okay, so if we stick that in our calculator, that is going to give us 625 units squared. Yeah, so then what's our final area? Well, it's 625 take away 400, so that's going to be 225 units squared. Okay, so let me just give us a marks for this. So the first mark you're getting is for your linear scale factor, right? The second bit is for knowing to square it and times it by 400, which I think is a bit harsh, but okay. Third mark for actually working that out, finding the area, and the fourth mark for answering it. Okay, I think you should have got a mark for the strategy, but I suppose the strategy is kind of the bit at the end. But I feel you should have a mark for strategy. But that's where your 4 marks are coming in. Okay, I've still got a minute to go. So look, with these questions, having a nice wee diagram is a good start. Okay, think of your strategy. Always work out a scale factor, and then think what you're trying to work out. If you're trying to work out a length, you'll be using your scale factor. That's fine. Trying to work out an area, you need to square that scale factor to get your area scale factor. Trying to work out a volume, you need to cube it. Okay. Sometimes they give you the volumes and make you work back the way. Okay. In that case, you would need to cube root it. Okay. You need to go from, you need to say, well, linear scale factor cubed is volume scale factor. So therefore, linear scale factor is volume scale factor cube rooted. Okay, so I don't have time to go into loads of alternatives just now because I'm running out of time. But yeah, I think we can see what's gone on there. Valid strategy, work out your linear scale factor, turn that into what you need, area or volume scale factor, then do your multiplication. So we did the area times the area scale factor to get the new area, and then we just remember to answer the question. Okay, good stuff.